In this problem, we have two charged spheres on a frictionless track. Sphere A is in a fixed position, but sphere B can move in one plane, so towards A or away from A. They both have the same mass, and the question here is at what speed will sphere B be moving at when it reaches a distance of 1 meter from sphere A? So what you need to take a look at is when the two spheres begin, so at the point that they are 0.45 meters from each other, there only exists electrical potential energy. So let's go ahead and draw that first. So we have sphere A, and it is 0.45 meters away from sphere B. And we have the charges in the question. So negative 3.0 times 10 to the negative 4 and negative 5.6 times 10 to the negative 5. We then are in a situation where sphere B is allowed to move, and it's going to start to move away from sphere A. This is because they are like charges in the sense that they're both negative, so they're going to repel. And A is fixed, so B is the only one that's moving. So say B ends up over here, where we are now 1 meter away. So in the beginning, all we have is electrical potential energy. And after 1 meter of movement has occurred, we still have some electrical potential energy because that's always going to be present. But whatever is left over is now all kinetic energy. So we can substitute what we know to be the variables that make up EE and EK. So this leaves us with K Q1 Q2 over R is equal to K Q1 Q2 over R prime plus 1 half M V prime squared. We can also go ahead and rearrange this so that it equals V. So what we're going to do is we're going to bring over first this entire term. So we have K Q1 Q2 over R minus K Q1 Q2 over R prime. That's equal to 1 half MV prime squared. I'm then actually going to go ahead and factor out the K Q1 Q2. Then I'm going to bring over the 1 half and the M so that I'm left with just a value for V. So what I have is V prime. It's going to be equal to the square root of K. Actually, you know what? We'll start with 2 over M times K Q1 Q2 times 1 over R minus 1 over R prime. So that would be how this equation would be rearranged like you'd solve for V or V prime. After you go ahead and substitute everything, it'll look something like this. So 2 over M, which is 1.3 times 10 to the negative 2. I'm going to omit units just so I can make sure I can fit everything. Our value for K is 9 times 10 to the 9 Newton meter squared per Coulomb squared. It doesn't matter which Q is Q1 and which is Q2. So 3.0 times 10 to the negative 4, negative 5.6 times 10 to the negative 5, and then 1 over 0.45 minus 1 over 1. After punching that into a calculator, you're left with 168.6 meters per second. To two significant figures, that's 170 meters per second. So that's the velocity of sphere B after it is 1 meter away from sphere A.